Hi all, this is lesson 2 in geometry. If you were in the 2018 class, we've already done two of the proofs that come with this section, but I didn't get a chance to do the third one. But we're going to do a quick review of what we talked about in case you want to go over it again. We talked about the properties of equality, and the main one we're going to be using in this lesson anyway is if A equals B and C equals D, then A plus C equals B plus D. We'll also be using the subtraction property that you can subtract. It's the same as the addition one, only instead of saying A plus C, we're going to say A minus C equals B minus D. The multiplication property is you can multiply both sides by the same number and it stays the same. The division property of equality says that you can divide both sides by the same numbers. C cannot equal 0. Then A divided by C equals B divided by C. The substitution property says if A equals B, you can substitute in B for A in any of the equations. Reflexive is just kind of an odd one. A equals A, we're going to use it frequently. Symmetric, if A equals B, B equals A, you can just switch the sides of the equal sign. And the transitive property, which I said was my favorite, is A equals B. If A equals B and B equals C, then A equals C, transitive property. We can also talk about congruence. If we have a segment equals each other, that's talking about a specific length, a measurement like 3 equals 3. If we have the congruent sign, which looks like this, it means that the images are the same. And the same with the angles. Measure of angle D equals measure of angle B. E would be like 30 degrees equals 30 degrees. But when we say angle A without the M is congruent to angle E, we're saying the images lie right on top of each other and they're exactly the same. The properties of congruence are the same as the properties of equality. We have the reflexive. If they're the same, they are the same. So DE is congruent to DE, angle D is congruent to angle D. These would have a line on top of them, straight line, if they're congruent. So we would say if DE is congruent to FG, then FG is congruent to DE. That's a symmetric property, and the same with the angles. And then the transitive property, if segment DE is congruent to segment FG, and segment FG is congruent to segment JK, then segment DE is congruent to segment JK, and the same with the angles. So let's quickly go through a couple proofs. We did this first one, it's just an algebraic proof. We are to solve this. So the first step in every proof, well, you should have a diagram, is to mark the diagram, but we'll get to this later. We don't even learn to do proofs for a few more lessons, so this is all introductory, so don't panic if you can't do a proof yet. So first step in a proof is you write down the given. And you write over here the reason for that is it's given. And now we're just going to proceed to solve this equation like you were in algebra class. And in algebra, we always got rid of the fractions, or we should get rid of the fractions. We're clearing the fractions. We're going to multiply every term in the equation by 2. So we get 6x equals 12 minus x. And the reason that we were allowed to do that is multiplication property of equality. So we can just say the multiplication property. Then we would add x to both sides, so we get 7x equals 12, and that's the addition property. You could say the addition property of equality, or just the addition property. And then finally, we would divide both sides by 7. So we're just given a reason for each of our steps. So why can we divide? It's because of the division property. Division property. You can abbreviate these as well. We're going to be doing some big long theorems, so we're going to have to get our abbreviation game up to speed. So that was the first one. Now we had two that were more geometric than algebraic. So let's move on to those. We didn't get to the second one, so I'll cover that in this video. We are given that RT and PQ are intersecting at point S, so that, now we're going to mark our diagrams. That's the first thing you're going to do in a proof. So we have RS equals PS. So we'll have RS equals PS, and we have RT. Oops, I got some wrong letters going on here. I'm pretty sure this is Q. We have R. Let me just make sure the letters aren't from another Okay. Then we're going to have ST equals SQ. So we have these two. And we are going to prove, and I had this wrong in class, so let me fix this. RT equals PQ. That's what we're going to prove. We're going to prove, I have a variety of colors here. We're going to prove that RT, which is this long one right here, equals this QP. Now when you look at it, you're like, oh my goodness, this is common sense. We have, I'm just going to remove those right now. We have, since these are congruent and these are congruent, if I add a 1 with a 2, it's going to equal the 1 with the 2, right? But we're going to have to logically write this out step by step and have reasons for why we're doing what we're doing. So let's hit this. So first thing, remember I said you write down the given. This one doesn't really say anything, so we're not going to write that one down. We're just going to say RS equals PS and ST equals SQ. So our final step is going to be what we're trying to prove, which is RT equals PQ. So that's where we're trying to get to. Now we're going to use this addition property of, this is just called the addition property of equality. So it's the addition property says if A equals B and C equals D, then we can add these two together and they'll be equal to these two added together. So let's do that. We have this segment is equal to this segment. So we can add these two together and we can add these two together and they're going to be equal. So we're going to get RS plus ST equals QS plus SP. Hopefully I did that in the right order. RS, TS, and QS, SP. And these letters can be interchanged. You could say PS, SP. Oops, I didn't write my reasons. Okay, that was given. And this is the addition property. All right, we just have really one more step to get in and two more reasons. Now, we can say that RS plus ST equals RT because that's a segment addition property. If two segments lie in one line, if you add them together, they're going to add up to the larger segment. So we get RS plus ST equals the big long one, RT, and we're going to say QS plus SP equals the long one, QP. And the reason we can say that is the segment property of addition. Now, the final step is just plain old substitution. You see how, let me pull out another color here. You can see how RS, ST, and it's right down here, equals RT. So I can basically take this and put it up where that is, and that's right here. And we have that, let's see, we have this one, QSSP, that's right here. So instead of writing QSSP, we can write QP, which is right here. And we proved it, and all we did was substitute. We took this 1 and put it in where those 2 are, and we get that substitution. Now, I went rather fast on that. We did this one in class, and I can understand that you're like, where do you get all this? How do you figure this out? And we're going to be talking about this coming up in, let me see which lesson it is. It looks like it is in lesson 2.3 is proving theorems. Lesson 2.4 is theorems. I think 2.6 is when it says doing proofs. So this is all kind of introductory. We'll be working on the steps to doing proofs soon. So let's try one more for this video. This one's with angles. The same idea though. We're given angle AOC, A, this is O, C equals BOD. And we're supposed to prove that angle 1 is congruent to angle 2. So we have the two outer ones with the middle one included are congruent. So even if you don't know how to do proofs, you have no excuse for not writing the first step. So you say measure of angle AOC equals the measure of angle BOD, and that is given. And you can write the last step. Measure of angle 1 is equal to the measure of angle 2. Now, if we're talking congruence, we would have said the angle of 1 is congruent to the angle of 2 without the m's. All right, so now we have to work our way. This proof is going to be almost exactly like the previous one. So let's see if we can. I need to give you more time just to think things through because I'm going rather fast. You can try to prove it yourself. You can stop the video and try, or you can just try to get proofs by watching me do them. Now, we know that this big angle right here, angle AOC, is equal to 1 in measure of angle 2. That's the angle addition property. Just like up here, we said that this segment and this segment equals the big segment. That's the segment property of addition. So now we can say, I like having the numbers in it, makes it easier. We can say angle, the measure of angle, because we're in measures, of AOC equals the measure of angle 1 plus the measure of angle 2. And we can say the measure of angle, the other big one right here, BOD, equals the measure of angle 2 plus the measure of angle 3. And the reason we can do that is the angle addition property. Angle addition prop. All right, so the next thing we can do is we have up here that AOC is equal to BOD. We have AOC as measure of 1 plus measure of angle 2, and BOD is the measure of angle 2 and angle 3. So instead of writing AOC, we can write measure of angle 1 plus the measure of angle 2. So I'm going to do this, measure of angle 1 plus the measure of angle 2. That's instead of AOC in this first step. Now BOD is equal to the measure of angle 2 plus the measure of angle 3. And the reason that we can do that is substitution. Just write substitution. And then finally, if we subtract the measure of angle 2 from both sides, that's our next step. We're just going to subtract the measure of angle 2 from both sides. And that would be subtraction. Whoops, whoops, whoops. They stick another step in which we're going to eventually not have. They're saying the measure of angle 2 equals the measure of angle 2. I don't think that's necessary. That's called the reflexive property. We know that they're congruent. We don't need to say that or equal. I would have skipped this step and went right on to the last one. We're going to subtract 2 from both sides, and so we're going to get the measure of angle 1 equals the measure of angle 2. Whoops, I already have that down. And that's just your subtraction property. We are just subtracting angle 2 off of both sides. Since angle 2 is equal to angle 2, we can subtract it from the same side, and we get what we are trying to prove, so we have done another proof. All right, that's it for lesson 2.2. I look forward to seeing your questions on the communication board.